Hey, how's it going guys? Phil here, and today we're going to be repairing my Nesco American Harvest dehydrator. I have the Nesco FD-80A model dehydrator, which is square, though this process may be beneficial even if you have a different model. In my model, the heating element and fan are located in the cover, and what happened is that this unit no longer turns on when I plug it in, so I'm not getting any heat and the fan isn't spinning. This model doesn't have an on-off switch, and it's supposed to come on immediately when I plug it in, but as you can see, nothing happens. So first we want to make sure the unit is unplugged because we're going to open it up. I'm going to start by removing the 8 screws in this smaller ring here, holding the heating element on the underside of the unit. These are pretty easy to take out using a small Phillips screwdriver. You won't be able to remove the cover just yet, as it is attached by a cable on the inside. So next, we're going to remove the 6 outer screws holding on the top of the unit. Now these screws are really stuck on there, possibly with glue, so you need to apply a lot of downward pressure and torque to break the seal. You'll probably hear a loud snap with each screw. But don't be alarmed, you aren't breaking any pieces inside. Just make sure to go slow so you don't end up stripping the screws. After you remove the last screw, turn the unit right side up. The top should be loose now, so remove the temperature adjustment dial by pulling straight up on it. Then lift the white cover off. The first thing we'll do is disconnect the white power cord. Remove the screw with the red plastic washer, then lift the power cord out of its track. Snip the loop of zip tie binding the wires together, being careful not to cut the wires. Then remove the 3 wire caps. I like to label the wires as I go, so I'll remember which ones go together when I reassemble the unit. So for example, I'll label this strand red. Similarly, I'll label this side black, then set the power cord aside. Next, I'll separate these wires, again labeling this wire blue. Carefully flip the motor unit towards the side where the wires are still attached to the heating element. We'll need to remove the 4 screws holding the heating element to the cover on the underside of the unit. You can see one of the screws here is loose, and that's because the thread post that it was in has cracked and fallen apart. That's pretty common for plastic components given how close it is to the heating element. Note that this is not due to the snaps and pops you heard earlier when removing the screws from the bottom, because those attach to different points directly in the top cover. Remove the 4 screws from the heating element and gently lift it off the bottom cover. Now we're going to remove the 2 wire harnesses attached to the temperature controller. You should be able to just pull the connectors off the blades, but if you're having trouble, use a small flathead screwdriver to help you pry it straight up. Then lift the wires out of their guide clips. Now that we've freed the heating element, the most likely point of failure here is the thermo cutoff fuse. But first, let's rule out that the motor could be the problem by hooking it back up to the power cord. In this case, I'll attach the black wire to the side of the cord labeled black and the blue wire to the side labeled red. Then, make sure the fan is facing up and not touching anything. And then plug the power cord in. And right away it comes on and starts spinning, so we know that's not the problem here. Taking a closer look at the fuse, its part number is SF139E with a 142 degree Celsius cutoff value. We can test this fuse by using a multimeter set to the continuity setting. When there is continuity, like when touching the 2 probes together, you'll hear an audible beep. We need to make sure that the fuse has continuity, which means that it's intact. So we'll touch the probes to the leads on either side of the fuse. And we get nothing. Check again just to make sure. And it's still open, which means the fuse has blown or burned out. When we check the heating coil, we see that it has continuity, so the problem here is definitely the fuse. Now we're going to have to carefully remove the fuse from the heating element. Since the base of the heating element is a heat-proof cardboard, you want to be careful not to bend it. Lay it on a flat surface and use a small flathead screwdriver to carefully wedge open the clips holding on the fuse. Once it's loosened a bit, you can use needle-nosed pliers to pull the leads of the fuse out of the crimps. It does take a bit of effort and determination though. Alright, so here's a new fuse that I bought online for a couple of bucks. And when I test its continuity, now I'm hearing the beeping tone. So let's go ahead and install it, making sure the black end is to the left, facing the negative side of the circuit, or the black wire. If your leads are too long, trim off the excess. Seat the fuse into the crimp connectors and squeeze the ends closed using needle-nosed pliers on both sides. Now we can verify that there is continuity between the black wire and both the red and white wires. When replacing the heating element on the black cover, pay attention to the small pegs. 3 of them are long and 1 is short. The short one goes in front of the fuse, while the long ones go into these 3 holes. Then replace the 4 screws that hold the heating element onto the cover. On the plastic housing, keep track of where the plastic cord guide is located. When placing the heating element and the cover back into place, make sure the wires are on the same side as the cord guide. Then flip the assembly over. Place the fan unit over the heating element and make sure the wires pass up through the notch on the side of the fan housing. Flip the unit back over and adjust the position of the cover until it locks into place. Then replace the 8 smaller screws for the heating element cover. I like to install them in a star pattern, like when putting tires on a car, because it helps to stabilize and keep the cover from moving around when you do this. When all the screws are in place, flip the unit back over. We'll reattach the wires together, making sure to match them up based on our labels. So this one goes to the blue wire, this one goes to the red, and this one goes with both the black wires. Now reattach the wire clips to the blades on the thermal controller, which I've labeled left and right since they're both black. Then they can go back into their wire clips. I'll zip tie the wires back together as they were when I opened up the unit, just to keep the wiring neat and organized. Then snip off the excess. Wrap the power cord back into the guide slot and replace the red washer and screw. Now put the top piece back onto the unit, making sure the power cord exits out the back. And replace the temperature control knob, ensuring the notch here lines up with the post underneath. Check that you're able to set the min and max temperatures correctly. Lastly, flip the unit over one more time and install the 6 outer screws that hold the top cover to the rest of the housing. Okay, so the final test will be to make sure the unit is heating up properly. Right now, room temperature is about 68 degrees Fahrenheit. When I plug the unit in, you can hear it come on. And when I hold the thermometer near the airflow, you can see it rise in temperature quite quickly, and I can feel the warm air blowing out of the machine. So for only a couple of dollars for the cost of the fuse, I was able to get my dehydrator working again, and can continue to enjoy making fruit leathers, jerky, and dried goodies without having to buy a brand new dehydrator. I hope you enjoyed this repair video. I'll put links to the parts used in this video in the description below. Don't forget to subscribe to my channel and join me next time.